Hi everyone, in today's lesson we're going to talk about the basic differentiation rules. The four main derivative notations that we need to be aware of is f prime of x, which you seem to know from the limits. Dy dx is another way to write it. D dx with f of x next to it, and dy dx with a line at a certain x value, at x equals a. So we're going to discuss three derivative rules today. The derivative of a constant, and here's the textbook definition. If f is a function with a constant value c, then df dx, or ddx of c, is equal to 0. Now I know that kind of sounds like gibberish, but basically what that means is the derivative is defined as the slope of a tangent line at any given x value. So say we have our constant value being 3. What is the slope of the tangent line at x equals 3? So let's just draw up a quick sketch of this. Here is the line y equals 3. And the slope of any tangent line is literally just going to be this line here, and that slope is 0. So anytime you have a constant function, the derivative is simply 0, because the slope of any horizontal line will always be 0. So if I give you f of x equals 4, and I'm asking you to find the derivative, it's asking you to find the slope of the tangent line, which at any constant value is 0. Same thing for -1. And same thing for 1/2. The slope of all of those will just be 0, or the derivative will be 0. Okay, let's look at the power rule. Here is the textbook definition of the power rule. Basically what it says is if I take any power or any exponent and raise it to a power, the derivative, d dx of that, the derivative is when I bring the power in front and multiply it by x to the n minus 1, which is 1 power less. So in English, it means take the exponent and multiply it in front, then drop the original power by 1. So if I have f of x equals x to the 5th, and I want to find the derivative of that, I take the power, which is 5, and I drop it in front. So I have 5x to the, and then drop the power down to a 4. And that's it. Same thing with number 2. I take the 7, drop it in front, leave the x, and drop the power to a 6. And same thing for number 3. I take the -4, bring it in front, keep the x, and drop the original power by 1. That means, when I say drop the original power by 1, that means subtract the power by 1. So in this case, when I have -4 and I want to subtract 1, I get -5. All right? And that's it for the power rule. Let's go to the next page. And on the next page, it says the constant multiple rule. So what the textbook definition says, it says if u is a differentiable function of x and c is a constant, then d dx, the derivative of c times u, is c times the derivative of u with respect to x. So what does that mean? In simplified definition, multiply the constant by the derivative of the function. So it's so simple. This one is 4x, right? So you could break it up into 4 times x to the first. So what do? We take the derivative of this function and multiply it by 4. So this is the power rule, the derivative of x to the first. Well, what does that mean? We take this power, drop it in front. So we don't need to really write that, but it would just be x to the 0 power, right? We take the power of a 1 and drop it down by 1, so we get 0. And x to the 0 power is just 1. And the answer is just 4. So 4 times 1 is 4. So in simplest terms, if I have another function, f of x times, say, 3x, the derivative, f prime, is just 3. Same thing as if I had the derivative, if I have f of x of, say, 5x, the derivative, f prime, is just 5. So it's just the number in front. That's all. Okay, so number 2, f of x equals -x to the third. So the same concept is just you take f of x, and you could rewrite it if you want as -1 times x to the third. And the derivative of this piece, using the power rule, drop the 3 in front, keep the x, and drop the power. Just take that and multiply it by a -3. Excuse me, a -1. So the answer would be -3x squared. Now, you don't have to break this up every single time like this. You literally can just combine the power rule. So basically, you have -5 times the -2, x to the -3 power. Make sure, again, you take this exponent and drop it down a power to -3, or subtract 1. Okay, so it's -2 minus 1, which gives me that power of -3. Okay, so the final answer would actually just be positive 10 x to the -3. Okay, and the last rule is the sum and difference rule. And I'm just going to read the simplified version. Basically, it says to take the derivative of a sum or a difference, you take the derivative of all of the terms separately. So if I want to take the derivative of this f of x function, I'm going to take the derivative of all of the terms separately. So the derivative of 3x squared is the combination of the power rule and the constant multiple rule. So I'm going to take this power of 2 and drop it down. And when I drop it down, I'm multiplying it by that 3. So it's 6x. And then I take this exponent and I subtract 1. And I'll get 1. So I'm just going to leave it as 6x. And now this one here, this middle term, when I take the derivative of 2x, it's going to follow the same rule as this one up here. The derivative of 4x is 4. So the derivative of 2x is just 2. So plus 2. And then the last but not least, the derivative of -10 is 0, because the derivative of a constant, like we learned in the first rule, is 0. So I'm just going to write plus 0 so you know. And then the final answer is 6x plus 2. All right, same thing with example number 2. We're going to take this -3 power, and we're going to drop it in front and multiply it with that -1. So that would give me positive 3. Keep the x, subtract -3 by 1, and you get -4. Same thing with the second term. Take the -1, drop it in front, and you get -5, because you're multiplying it by that 5, x to the -2 power. And it's a -2 power because I'm taking this -1 and subtracting 1. The next term is 1x, and I want to take the derivative of 1x, which is the same as derivative of 4x, derivative of 5x, derivative of 2x. It's just the coefficient in front, so the derivative is just 1. So plus 1. And then the derivative of this -8 is a constant, so that's 0. Again, you don't have to write it, I'm just showing you all the pieces. So this final answer is 3x to the -4, -5x to the -2, and then plus 1. And that's your final answer for the derivative. So I could just rewrite that as f prime of x. Same thing over here. This is f prime of x. Okay, so now let's look at the last page and do some examples where we're putting it all together. Okay, so the first one, find the derivative of each. The first one, again, is just like the ones we just did. So we're going to take this power of 2, bring it in front, multiply that by the 5. So we get 10x, and then we're going to subtract the power. And the power, 2 minus 1 is 1. Minus the derivative of -1x is just -1. So my f prime is 10x minus 1. And remember, the derivative of a constant is 0, so that's why I'm not writing that. Okay. Number 2, same concept. We're going to take the power, drop it in front, and multiply the -2 by the 3. So f prime of x is going to give me -6. X to the -3. -3 because we're taking a -2 and subtracting 1. Then I'm going to take this -1, bring it in front, and multiply it by this negative 1, and I'll get a positive 1 x to the negative 2. Again, negative 2 because I'm subtracting negative 1 minus 1. The derivative of 7x is just the 7 in front. Think of it as the slope. And then the derivative of negative 5 is 0. So I'm not writing that. Okay, number 3 is a little bit trickier because we have these fractions. And you want to use a trick. You don't have to write it as fractions. Would you agree that I could bring this exponent up to the numerator? And by doing so, it would be, keep the 3, x to the negative 4. Because remember, negative exponents can be moved up or down as long as we negate them. So the same concept is I could bring this guy up, and this would be negative 1x to the negative 3. Same thing for the x squared. And same thing for the x to the negative 1. Except in this case, it's already negative down here. So if I bring it up, it actually becomes positive x to the first. And then we have plus 9. Okay? So this is just f of x. And what I'd like you to do for homework is see if you can find the derivative of this function, modeling it just like we did questions 1 and 2. All right? And now number 4 is a little different because we have to rewrite those radicals as exponents. So if you remember, it's x to the power over root, which equals the x root, right, of x to the power. So for example, the cube root of x, since the root's on the outside, the root will go on the bottom and the power would be 1. So this power would be 1 here. So this one is just x to the 1/3 plus, there's a big 2 here which we'll leave, x to the, 5 is the root, 2 is the power, so 2 over 5. So x to the 2 over 5 minus the 7, x to the root is 4, the power is 3. So 4 and 3, so 3 over 4. So all we did was rewrite this function using exponents. And now we can use the power rule. Okay, so we're going to take this power, bring it down. So 1/3 x. And now we're going to subtract 1/3 by 1. Right? That's the process. Now, you could type that into the calculator if you want, or you could recognize that it's the same thing as saying 1/3 minus 3/3, which is negative 2/3. You might be better off doing it by hand. Okay? Plus, now we're going to take this 2/5, bring it down, and multiply it by that 2. So 2 times 2/5. Remember, when you multiply fractions, you multiply the tops with the tops, bottoms with the bottoms. So that's 4 over 5. Again, you could always use the calculator. X to the, now we have to take that power, 2/5, and minus 1. And when we subtract 1, it's the same thing as saying 2/5 minus 5/5, which is a negative 3/5. Okay? Now for homework, so this is f prime, I just want you to tell me what this last term is here in the derivative. So just finish this one quickly, and then finish this one, and we will go over this tomorrow. If you're confused, don't worry. We're going to spend a couple days on this in class until everyone gets it. All right, have a good night.